Emission duration is defined as the amount of time a substance is emitting photons for. According to the hypothesis, emission duration is completely dependent on energy input and independent of the emitting substance. As seen in the last video, energy input is defined as the total amount of energy a system is exposed to. For this experiment, energy input came in two forms: chemical energy from the reaction between the dyes and activator, and heat energy from the warm water the chemicals were placed in. For our predictions, if duration was only affected by energy input, all of the glow sticks would emit for the same period of time. This is because the red, green, and 1-to-1 mixture of the dyes were all exposed to the same amount of activator. Meanwhile, all three solutions were placed in the same heat bath for the same amount of time. This means that they were exposed to the same amount of chemical and heat energy. Therefore, for this prediction, they would have the same duration. Meanwhile, if only the molecular composition of the dye affected duration, the prediction would look like so. The green would have the shortest duration time because it is releasing the highest energy photons. This means that it is using up the available energy the fastest. Next would be the 1-to-1 mixture, as it is releasing some higher energy and some lower energy photons. The red dye would emit for the longest period of time as it is using the available energy the slowest. In total, the energy released through emission will be equivalent to energy input and thus the same for all three solutions. This can be checked by calculating the area under the curve. By taking the integral of each emission equation, the area is calculated. This area will then be multiplied by the duration. The area multiplied by the duration for the green, red, and mixed dyes is equal. Based off of the given equipment, the duration of the emissions could not be measured. The spectrometer measures a snapshot of emission, not the whole time. To counteract this, data was measured at every minute. We found that once placed in the heat bath, there was an initial increase in intensity as there was more energy input. However, after some time, the intensities began to decrease. First the red, then the mixture, and finally the green, all stabilized back down to zero emission. This disproved the hypothesis, as with the same amount of activator, the dyes displayed different duration. When using the equation, total energy equals the intensity of the peak at full width half max times the energy of the photon times duration of emission. All three data sets yielded the same number. Therefore, they absorbed and emitted the same amount of energy. Imagine there are three people in a cold room. The temperature of the room represents the energy input. The more input, the warmer the room. Each person has a different sensitivity to cold. This represents their molecular composition. When placed in the room at the same time, each person has a different amount of time they can remain in the room before the cold gets too much. The time they remain in the room represents duration of emission. From the analogy, one can see that the colder the room and the more sensitive someone is to temperature, the less duration they will have. This means the less input and the more higher wavelengths are emitted, the smaller the duration.